Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Also, if you find my videos interesting and important to your studies, don't forget to subscribe. Draw the influence line for the vertical deflection at point C of the simply supported beam shown below. EI is constant. So here is the figure. And let's put the unit load at C. Then let's compute for the reaction. So the reaction at A is downward. Reaction at A times 14 equals 1 times 4. So therefore, the reaction at A, which is downward, is 4 over 14 or 2 over 7. So likewise, if we sum up moments about A, reaction at A times 14 equals 1 times 18. So reaction at B is 18 over 14 or 9 over 7 upward. So by double integration method, EI y double prime FCD or FDC is equal to 9 over 7 times x minus 14 minus 2 over 7 times x. Integrating once, EI FDC prime equals 9 over 14 x minus 14 square minus 1 over 7 x square plus c sub 1. So there is slope at A, but there's no deflection at A, so C sub 2 is 0. So EIFDC is equal to 3 over 14 x minus 14 cubed minus 1 over 21 x cubed plus C sub 1x. Computing for C sub 1 by setting x is 14, FDC is 0, or deflection is 0. So 0 is negative 1 over 21 14 cubed plus C sub 1 times 14. So C sub 1 is equal to 28 over 3. So therefore, EIFDC, which is equal to FCD, or FDC equals FCD, is 1 over EI quantity, 3 over 14 x minus 14 cubed minus 1 over 21 x cubed plus 28 over 3x. So this is the equation of the elastic curve, which is also the equation of the influence line for vertical deflection at C. And we will compare this with the equation for FDC, FCD by the conjugate beam method. So by the conjugate beam method, let's make C as our moment center. So this would be the conjugate beam. This interior roller becomes a hinge. This free end becomes fixed. This hinge pinned is remaining to be a pin. So since we make this as the moment center, 2 over 7 times 18 equals 36 over 7. So at B, 2 over 7 times 14, 28 over 7 EI. In general, at distance x, 27, 2 over 7, 2x over 7 EI. This is the moment due to the 9 over 7 reaction at B. So 9 over 7 times 4, 36 over 7 EI. So which is the same as this. So call this theta B, which is theta B at the left, which is also theta B at the right. Then this is theta D FCD at this section X from A. So this is 2 over 7, 2 times X over 7 EI. While this is 9 over 7, this distance is X minus 14. So 9 over 7 EI times quantity X minus 14. So let's call this theta A, which is positive upward. So let's compute theta A by considering AB. Then we sum up moment about B, considering AB. So theta A times 14 plus 1/2 of theta A times 14 plus 1/2 of 14 equals, sorry, theta A times 14 equals 1/2 of 14 times 28 over 7 EI times moment arm 14 over 3. So theta A is equal to 28 over 3 EI. So that is the same as the double integration method because C sub 1 divided by EI is the slope at A. It's the same as this. So therefore, at this section, we do not care or mind theta B and theta B because it is in equilibrium by itself. So at this section here, summation moment about D equals 0, counterclockwise positive. So FDC plus 1/2 of x times 2x over 7 EI times moment arm x over 3, then equals moment due to theta A times x, so 28 over 3 EI times x plus moment of this load 1/2 of x minus 14 times 9 over 7 EI times x minus 14 times moment arm x minus 14 over 3. So simplifying, FDC, which is equal to FDC plus x cubed over 21 EI equals 28x over 3 EI plus 3 over 14 EI times x minus 14 cubed. Transposing this to the right and factoring out EI, so FDC, which is equal to FCD, is 1 over EI times the quantity 3 over 14 x minus 14 cubed minus 1 over 21 x cubed plus 28 over 3x, which is the same as that. So let's now have the influence line for the vertical reaction at C. So M is the center between the supports, so 7 meters from A. So substitute here, we'll get uh, the deflection influence ordinate for deflection at C is at M is equal to 49 over EI. Then at C, substitute X is 18 in this equation, we'll get negative 96 over EI. So at x equals 7, we don't mind this term because this is negative. The quantity in the parentheses is negative, just like in the double integration method. That's the ruling. So negative 1 over 21 times 7 cubed plus 28 times 7 over t will get 29 over EI. When x is 18, so 3/4 of 4 cubed minus 1 over 21 of 18 cubed plus 28 times 18 over 3 will get negative 96 over EI. So this is the equation of this curve. 1 over EI times quantity 3 over 14 x minus 14 cubed minus 1 over 21 x cubed plus 28 over 3x. And that's the influence line for vertical deflection at C in meter per kilonewton. So that's it for this problem. I hope you were able to follow the solutions.